Hello everyone, this video is not a programming video, but this is for programmers. And this is not only for C++ programmers, but programmers across the board. Because if you listen to me, I believe you will end up taking a better decision in your programming career at some later point of time. Now, it may sound weird, but I was never a fan of object oriented programming. I understand it's difficult to digest because in last 2 3 decades object oriented programming has ruled everything, so much so that any programming interview wasn't complete without asking questions on object oriented programming, the encapsulation, polymorphism, the design patterns, the solid pattern, and so many things. Somehow I understand the construct, somehow I also understand the usability of it. But one thing always troubled me is that when you talk about design patterns or solid principles, they are a solution. And you are giving me solution without understanding my problem. So you are telling me to utilize some pattern, you do not know my problem. So basically, I have a solution before anybody can look into my problem. It may be good for some of the problem domains, but giving a blanket statement that this particular pattern or this way of writing code is better for all the problem domain was beyond my understanding. That's why I was not a great fan of it, so much so that I've actually created a video last year stating that object oriented programming is not a problem solving technique. It's just a data arrangement technique. I'll highly recommend you to go ahead and see this video because when we write our code, when we create our programs, we try to solve the problem, and object oriented programming is not a technique to solve the problem. It's a technique to arrange the data. And why I'm talking about this in context of C++ STL, because I believe C++ STL has proved me right. And we are going to see how. So, what is a program? Any program in any language, a program consists of only and only two things: data and functions which acts on that data, as you can see in your screen right now. There is nothing else that is there in a software program. It just has data as well as functions which acts on that data. And what object oriented programming says that the related data and functions, you club them together and you create a class. So it's a data arrangement technique in a software program where we are saying that, okay, you know what? We do not want your data and functions which acts on that data to be cluttered around in different places. You combine them and keep it at one place. That's clear. That's understandable. And that's okay for most of the cases. But I'm going to talk about one particular case. Assume you are creating a class called awesome algorithm, or you are creating an awesome algorithm. And since you have to create a class as per object oriented programming and you have to keep the data related to that algorithm in that particular class, so your class will look something like this, what you are seeing on your screens right now. Like, you have a class called awesome algorithm. It has a string data type and you have your awesome algorithm implementation. So far, so good. But what if you got another data type? Right now, your awesome algorithm works on string data type. Now, you need to make sure that the awesome algorithm works on int data type. What will you do? So, in terms of object oriented, you will either derive it or make the function, work on int as well as, string. Now, tomorrow something else can happen. Like I want to use the awesome algorithm in an array of integers or array of strings or array of any specific data types, array of vectors, array of maps. What will I do? Now, here you are seeing the discrepancy, right? Your algorithm works on data, but may not be directly dependent on data. What I mean to say over here is that your awesome algorithm will not change based on what is the data that is there. It's just the data comparison that matters. Rest of your awesome algorithm will be same. Just like all your sorting algorithms just need one thing. If you compare two items, which is greater, which is lesser, or are they equal? Whether you are comparing a string, objects, numbers, floating point, or anything for that matter. So ideally, your algorithms are independent of data. Because imagine that you are going to create your algorithm for each data type. There will be hundreds of data types. Consider this situation similar to your airport queues. Of course, there are some different queues for, dignitaries or between business class and economic class, but you cannot imagine a separate queue for each and every individual based on their own, you know, preference, type, size, number of luggages, etc. Right? When these queues are designed in an airport, they don't even know about the people that are gonna come in. There is no way you can create more than two, three queues. Okay, it's not possible to maintain beyond that. Just as these queues are independent of people, the algorithms are actually independent of data. It will work on data, but you cannot create multiple copies of the algorithm for each type of data. And that's where STL comes into picture because STL breaks this dependency. And this also breaks what we are told as per object oriented programming that you club your data and functions. That means data and algorithms together. Now, disclaimer, I'm not making a generalized statement. It may be true, may not be true, but most of the cases, when your algorithm is working on multiple data types, this acts as a binding, and that binding shouldn't be there. Let's see the design of STL and how it breaks the dependency. So basically, STL has three things: containers, iterators, and algorithms. So here is what these three things do. Containers are the data storage. It stores your data, whatever type of data that is. It is going to store your data. It is going to store, you know, key wise or insertion wise. It can store data the way you want. Okay. Algorithms that manipulates that data, changes the form of the data, but algorithms are independent, containers are independent, they interact with each other via iterators. And as you can see, the iterators provides a mechanism for accessing the data that is there in the container. We can read as well as write the data in the container if data needs to be changed. For example, I have an algorithm called 2x, which means all the data will be multiplied by 2x. The iterator will give me the way to multiply every data by 2x. I don't need to know whether the data is stored as a single integer or in array of integer or floating point or something like that. Okay. So in a nutshell, design of STL is like it is more focused on understanding how you want to store the data because you are worried about retrieval time and manipulation and storage time of your data. So focus on data, how you want to store your data. Leave the algorithms aside. Algorithms may come and go. Algorithms may expand. Algorithm may change its own types and it can give you multiple options. But that should not impact the way you are storing the data. And algorithms should not work the way you are storing your data. Okay. And that's where, I like the design of STL because it is purely focused on how you want to store your data first. So, for example, in standard template library, STL, there are two kinds of containers. One is sequence containers, one is associative containers. The name you can see over here, vector list, DQ array, and forward list are sequence containers, set, multi-set, map, and multi-map are associative containers. And these are not unique to STL. Pretty much all programming languages, we have something like map, dictionary is there in pretty much all the programming languages. Okay. Arrays are there, right? So in terms of STL, the data that is there as a sequence container based on the way you are inserting in sequence and associative containers are based on key, they are key value pairs. So these are similar data types. But the bigger things are iterators. Iterators, as I talked about, they provide a way to access the data that are there in the containers. So every container will have its own associated iterators. Iterators, you can think of it as a door or doorkeeper via which all the data that are there in your container will be accessed, retrieved, read, and modified. And algorithms are the functions which actually changes your data. Okay. Some of the well-known STL algorithms are sorting, searching, modifying, non-modifying, numeric. And this is what you will mainly do with your data, irrespective of what programming language you use. So this breaking of dependency between the data storage and data functionality is what I used to do since the very beginning of my career. And I found it really useful to segregate the data and the functionality associated with it. Because, it's a misconception that whatever data you want to use, you will get it in your class. No, most of the time you are going to get the data from the database, external cache, REST API calls, and many other things. They are not dependent on the functionality you create. It's not needed to take it in a class, then do something about it. Your data can remain independent, your functionality can remain independent, and you can create a protocol. I will call it iterator over here as a protocol to access the data in your containers. And this will also enhance the safety and security of your data. Okay? Because you have only one way to access the data, that is the protocol, in this case, iterator, and in your case, you can create something different. Okay, so I do hope and believe that I was able to communicate what I wanted to communicate as part of this video. And I seriously hope and believe that this will help you in taking better decisions for your upcoming software projects. Thank you all. Thanks for watching.